Hi, welcome to the IBM Spectrum Protect 715 technical overview. My name is Trisha Jong, and today I'll be walking you through the Spectrum Protect server and Spectrum Protect Operations Center version 715 updates. My colleague Sean Sperry will be covering the Snapshot 414 updates in a separate YouTube video. Spectrum Protect 715 became available on March 11th, 2016, and it just is for the Spectrum Protect server and the Operations Center. Back in fourth quarter of 2015, IBM acquired a company called Cleversafe, and Cleversafe is a content repository solution that delivers data availability at the petabyte level. And we're talking about object storage here, both on-premise, hybrid, or off-premise solutions. Spectrum Protect in version 715 is able to utilize the Cleversafe as a container storage pool. We introduced container storage pools for cloud storage back in 713, and so what we're adding in 715 is the ability for Spectrum Protect via an S3 compatible API to utilize the Cleversafe storage as the container storage pool, utilizing object storage underneath. A couple things to notice on this picture is the assessors are important in the Cleversafe world, and we're going to be utilizing those to connect Spectrum Protect with the underlying storage. Another thing to notice is that Cleversafe does have multiple APIs that you can utilize to connect with it. For the Spectrum Protect enhancements, we will be utilizing an S3 compatible API, even though back in 713 we introduced an OpenStack Swift API to connect with other types of cloud storage. The command line to define Cleversafe as a storage pool is the define storage pool, cloud pool, or whatever name you want to give it. Storage type equals cloud, cloud type equals S3, cloud URL equals the assessor address, and then the ID and the password are going to be the Cleversafe API ID and password. So let's break these down. First of all, we are using the Amazon S3 protocol. Currently, it is only supported for Cleversafe. We have not tested it to work with other object storage. And the reason we chose to use the S3 is that it'll use fewer bigger buckets to write the data into versus Swift protocol, which used a lot of smaller containers. All of that's under the covers, but just so you know why we chose S3 over Swift. The cloud URL is going to be the Cleversafe assessor IP, and you might actually have multiple assessors, and if so, you'll simply separate them with a bar and no space. Now the ID and password are going to be the API key and API password. They are not the administrator password for Cleversafe. In order to set up the Cleversafe, you will need to go in and do a vault template and make sure you have disabled the secure slice, disabled name index, and enabled recovery index. You'll also want to make sure you have vault provisioner role. So here over in this picture, underneath security inside of Cleversafe, you'll be able to find the access key ID as well as the password, and you'll be able to verify that you do have Vault Provisioner access. Now, our developers developed this with a on-premise appliance. However, it should work just fine with a hybrid or off-premise appliance for Cleversafe. But of course, your performance will depend upon the location that this is at. If you do not want to use the command line, you can go through the Operations Center to set up Cleversafe storage pools. In the storage pool area, you'll click on the plus storage pool. You'll give the container a name and select which Spectrum Protect server you want it to reside on. And then the important part here is you'll choose an on-premise cloud. Even if it is an off-premise cloud, choose on-premise, and then you'll go ahead and give it the API password, the URLs, and everything else. However, if this truly is an off-premise solution, you might want to go back in and update the container afterwards and turn on encryption, because by default, the on-premise clouds have encryption turned off. the first thing I want to say is that if you're looking at implementing cloud storage, really test it out first. Make sure that the data you're putting out on the cloud storage is still able to get the restore rates that you require for that application or for that end user. As you can imagine, the restore rates coming off of a cloud, especially an off-premise cloud, are probably going to be slower than pulling data from a disk or a tape. The other thing I'd like to suggest is as you implement these Cleversafe storage pools or any container pools, test the solution, ramp it up slowly, figure out which data belongs out there. So make sure you're testing and ramping up the solution slowly so that you are being able to recover the data and restore the data and get the rates that you need for those restores and recoveries. In order to optimize the performance, do utilize multiple assessors for the Cleversafe. And once again, on the cloud URL parameter, when you define the Cleversafe storage pools, you will simply divide the URLs by a bar with no spaces in between. The limiting factor on how many assessors you can use is the 255 character limit for the cloud URL parameter. Now your performance is going to be very dependent upon the network bandwidth and on latency rates. What we do see is that the more Spectrum Protect client sessions you have connecting in, the better throughput you'll see. In our lab, what we found under ideal conditions where we did have an on-premise Cleversafe with 3 accessor nodes, 10 gigabit network, we utilized the blueprint for large file workload. Lots of sessions coming in, and of course we went through and set up the default template so that we had the secure slice and name index disabled and the recovery listing enabled. And with those conditions, we've had about 3.6 terabyte per hour or 30 terabyte per day ingest rates. And once again, your restores are going to be a bit slower. So what I just talked about is in 7.1.5, we introduced the ability to define a container storage pool for a Cleversafe object storage. You'll utilize the S3 protocol, and it can be either on-premise, off-premise, or a hybrid solution. What we're going to talk about now is a new feature on inline server-side LZ4 compression for your container storage pools. And this would be for both directory and cloud container storage pools. We do have compression on the Spectrum Protect clients, but the Spectrum Protect clients utilize a LZW compression. So what we're introducing here is inline compression on the server side. And the nice thing about this is that it's going to increase the amount of space that's available for writing in our container storage pools. So although the compression doesn't take up additional database space, because you're going to be able to write more information out to the same container storage pool, you'll probably have more database entries tracking that additional information. In order to utilize server-side compression, you'll need to do an update on existing storage pools and say compression equals yes. Nowadays, when you do a defined storage pool for containers, by default, your compression will be yes. If you already have a container storage pool out there and you update it to use compression, it will start compressing the data that's written after you've turned on compression. It will not go back and compress existing data in that storage pool. LZ4 is a lossless data compression algorithm. It is more effective than our client-side LZW compression. So if you do have a choice between using server-side or client-side, choose the server-side compression. One thing to know right now, the server and client-side compression are not compatible. So if you are restoring compressed data from the server and sending it back to the client, the server will uncompress it before it sends it to the client. Now, when we go to ingest the data extents are going to be examined, and if they are suitable for compression, meaning that they're not metadata extents, meaning they were not previously encrypted or compressed, and making sure that they actually don't grow when we try and compress them, then we'll go ahead and compress them and write them out to the container. The order in which this happens is that dedupe, so server-side dedupe happens, then compression, then server-side encryption happens. This becomes important when we look at the performance of compression. So the CPU impact is going to vary depending on how well the data has responded to deduplication. If the data eliminated a lot of chunks, then all we have to do is compress the remaining chunks. Versus a workload where the data does not deduplicate well, you'll see a larger CPU impact on that. In the lab, we typically saw an additional 30% CPU cost for using the server-side compression. One thing to look for is that when the storage pool I/O becomes the bottleneck, then the data savings that we got by compressing data is going to make a large impact because we have to push less data through that bottleneck, and thus overall you may well see an increase in the aggregate backup throughput because the compression has gotten rid of a lot of data and therefore the bottleneck is being reduced as well. The blueprint systems that we document do have sufficient CPU to perform compression and still reach the published aggregate backup throughput, with the exception of the power blueprint for the medium CPU allocation, and we're increasing that from 8 to 10 cores, and that should be updated on the blueprints on the web. Also, we're updating the blueprint sizing spreadsheets to include CPU calculations and the cost of performing compression. So when you look at deduplication in conjunction with compression, you're going to see your space savings rates increase. For instance, if you originally had a piece of data that was able to dedupe at a 2-to-1 ratio, and then on top of that you were able to compress it at a 50% ratio, then in the end you're seeing a 4-to-1 space savings on that. When you go to replicate storage pools from one Spectrum Protect server to another for disaster recovery purposes, you will need to take into consideration compression. And remember, there's 3 basic factors here. The first is that inline compression was introduced in version 7.1.5. So only version 7.1.5 Spectrum Protect servers and above will even be able to support compression. Secondly, compression is only for container storage pools. So if you're replicating to a non-container storage pool, obviously compression isn't going to work. The third thing to keep in mind is that the container storage pools, even when compression is turned on, there will be some data in there that's not compressed. Remember, if it grew, if the data was already compressed or already encrypted, or if it was metadata information, or if data that was written prior to us turning compression on. So with those couple things in mind, when you go to replicate, it's going to be the target server that determines what happens with the data. So if the target server and the source server both have compression on, we simply send the data as it exists. If the target server is still using a container storage pool, it's at version 7.1.5 or above, compression is off, we're not going to take the time to decompress the data. We're just going to send it as it is. The only time you're going to start seeing us decompressing the data is if the storage pool is not a version 7.1.5 pool, if it's below that, or if it's a non-container pool. You will see us compress the data if we go from a container storage pool with compression turned off over to a container storage pool with compression turned on. If you want to take a look at the ratios we get for compression, you can either do a query storage pool, that will show the compression ratios. You can query the dedupe stats, we'll show them here as well. You can run a select from the storage pools table. And one other thing to remember is that if you do run an audit container, we will have to decompress those extents if we have to examine them for the audit. On the Operations Center, likewise, you can find out your compression ratios by going into storage pools and hovering over the Savings tab, or drilling down into the pool and looking at the summary. We'll have the savings there. Or if you go and drill down into the properties, not only will you see the savings, but here's where you could turn it on or off inside of the Operations Center. If you'd like to see what your potential savings are before you turn on compression, we do offer a Comprestimator, and it's available for all the server platforms. You can download it from this link here. And this is going to predict the compression results by reading at the volume level from a client system and then sampling ranges from within that volume. When we ran this Comprestimator tool in our lab, and then we actually turned on compression, we found that our actual compression savings were 15% higher than what the compressed Tomater gave us. Okay, so what I just talked about is a new feature called Inline server compression. It happens after the deduplication occurs. It's for container storage pools, both the directory and cloud container storage pools. It uses the LZ4 methodology, which is different from the client methodology currently. And it can be turned on by simply updating the storage pools. Okay, let's look at another new feature in 7.1.5, and this is the ability to migrate a Spectrum Protect server from an AIX platform to an xLinux platform. We do have other platform migrations available. This one previously wasn't supported because of the Indianness. P-Series is a big Indian architecture versus the Intel x86-64, which is your little Indian architecture. You could have previously used the imports or exports, but for large volumes, that's a lot of data and it might have been too time consuming. Also, if this was a System Storage Archive Manager server and was utilizing Centera, there might have been some locks that prevented the import, export, or node replication from working. So now in version 7.1.5 and above, you can utilize the extractdb and insertdb commands to do an upgrade. Our previous upgrade wizard that we introduced in version 5 is not supported on the AIX to xLinux, and the migration only moves the databases. It doesn't move the managed storage pools underneath it. Both the target and source server must at least be at version 7.1.5, and the source server is the one that has to be at the same level as the target server. You can do either a network method where we extract the data from the source Spectrum Protect server and transmit it over the network to the target database. Or you could extract it to a tape or a file media and then import it on the target server from there. We do have a white paper out there if you want to read more about that, and that'll walk you through the types of limitations that I cover here on page 14. Some things to keep in mind when you're looking at doing this AIX to xLinux server migration is things like target database space. You have to at least have enough on the source as you did on the target. You want to make sure your option files on the target contain options that are valid on the xLinux platform. With raw logical disk volumes, we don't support that on xLinux, so if you have that on AIX, you will have to adjust beforehand. You want to make sure that any of your storage pool devices are going to be supported on the xLinux. You want to go through and look at your disk or file storage and make sure that the target computer can also access that storage. You want to make sure your existing Spectrum Protect clients, that their option files are updated to point to the new server and that they have accessibility to that network as well. And finally, if the server is a library client, then you're going to need to look at the library servers and the path information for those shared libraries and drives. So what I just talked about is our ability to migrate from AIX Spectrum Protect server to an xLinux Spectrum Protect server utilizing the extractdb and insertdb commands. The next server enhancement we have is a Protect Stgpool enhancement where we now can replace damage extents on the target server. Now, Protect Stgpool was introduced in 7.1.3, and it's utilized to replicate the data extents from a directory container pool over to the target server. You still do need to run a replicate node in conjunction with the Replicate Stgpool to make sure all your metadata is being replicated over as well. Prior to 7.1.5, the Protect Stgpool and the Repair Stgpool were not able to identify and repair extents that were damaged on the target server. It only identified and repaired damaged extents on the source server. So in 7.1.5, we can now run an audit container, or when a client is trying to retrieve data off of the target and it noticed that an extent is damaged, either of those will flag the damaged extents. And so when the Protect Stgpool runs again, those damaged extents we will go ahead and the target will make sure if it has a copy of those, it'll send it over to the source server and replace the damaged extents. After the Protect Stgpool completes, the database inventory mapping cleanup will occur asynchronously. Now, some limitations with this repairing is, first of all, both your source and your target server will have to be at version 7.15 or above. The repair operation only works with directory container pools. It doesn't work with cloud container pools. And remember, it's not the repair operation that detects the damage extents. It's either the audit or when we're trying to access. If the extents belong to encrypted files, those will not get repaired, and this has to do with the hash values that are stored for those extents. There's also the possibility that when you use the replicate node and the protect stgpool commands together, that there will be some extents on the target server that don't exist on the source server. And so in this case, we would not be able to repair any of those damaged extents. Okay, so what I just talked about is a Protect Stgpool enhancement, where now we can repair extents that have been damaged on the target server and the source server. Some other links you might want to check out. We do have a couple blogs on Spectrum Protect, and there are other YouTube channels covering Spectrum Protect, including Sean Sperry's, who will be doing the snapshot updates for this version. Thank you for your time.